Okay, so about front end service. So in front end service, we were talking about auth, caching.
Sagar, whatever recording there, how we can take the recording? Suppose if we
So we
some
we
talk.
so we will upload it, like whenever I have time, I will try to upload it on a YouTube channel we had with the meetup,
No. Okay. Okay.
and then you can watch there.
Mhm. Okay. Okay. So, thank you.
Okay, so request deduplication. So with request deduplication, like there are various again hashing techniques which can hash the whole request blobs, and it can put it into and the hash key is basically used to look up whether the same request or whether the hash value exists in the cache. If it exists, that means the request is duplicated, so that request would be rejected, or that message would be rejected since some other request flow could have accepted it. And then usage data collection, that is more like a matrix collection. So then we came to out of after front end service, in the next component is metadata service. So someone asked the question, I think Nitika asked the question that why do we need the data metadata service. So now here we for load balancing purpose, as well as for scalability purpose, we were partitioning the queues. So by partitioning is nothing but breaking down the whole queue into number of different smaller queues, or we can call them smaller partitions. So there could be hundreds of such partitions. Each of them could be replicated into random instances. So there could be mappings which needs to be made, like which data is stored where, and where the data, where the copy of that data is located onto which instance, and like that. So all that mappings related data could be the metadata. Similarly, the config related data could be metadata. All sorts of these uh, data related to the original queue data or messages could be stored in a metadata storage. So metadata service is nothing but a client over the metadata storage. So metadata service could be called in for storing, retrieving, and updating the metadata. So now, whenever the request comes in, we need the metadata service to be updated, or the metadata storage to be updated. Or if it's a get request, then we need to look up to the metadata service to see where that data could be located, and then the request could be routed to that particular machine. So now it depends on how it routes. So there are two strategies that they are talking about. One is, if the metadata storage is small, then the metadata could very well sit with the our host or the partition itself. So if the metadata sits with the partition, we can route the request to any of the partition, and that partition, if that partition has the data, then it can give it right away. If that partition doesn't have a data, then same partition also has the metadata tables, so it can reroute that request to some other server where the data exists. So now we are saving one extra call that we are making to the data service. In turn, that call is being could be rerouted by the backend, by the partition itself. So chances are that the data could be found out locally, and that would reduce the overall latency. Whichever request is sent properly to the host partitions wherever the data sits. If the data is found out, basically if it's a hit, then that would reduce the latency. Else it could reroute the request to the intended host wherever the data is stored. This is slightly complicated. Like, feel free to ask any questions if you have, or we can discuss about if any clarification is required.
How does the request go? Like, I think I missed that. Like, does it check all the shard parallelly, or the server parallelly, or like it checks first? If it is not, then it goes to second.
If it's making a call to the metadata service, that means it is trying to check whether where the data exists, right? So if it is checking the metadata service, then it readily knows where the data is located. The request then will be routed to that particular shard or that particular partition. Okay. But if it is the second strategy where the metadata sits on the host, then the request can be routed to any server. Let's say we have three server. That means 1 in 3 chance that the data is found out locally. So 33% request could be served from a local server itself. Now, if any request from the rest of the 60% is comes in, then and the data doesn't exist locally, then it will look up into the metadata table and it will see that the data could be on server 2 or server 3, and then that and this server 1 could read out the request to server 2 or server 3.
So metadata services basically keeps the information like what server basically starts with what or finish ends at what key or whatever page it is. Something like that.
So metadata service keeps it updated all the time, and whatever is, the metadata information is, if it is small, then it could be kept at a server or it could be kept at a metadata storage separate. Doesn't like that's the only difference is where the metadata storage is kept.
So what kind of information does it have?
Like the same thing that I mentioned, right? Like where the data is located, like it's a table or the mapping.
Oh, okay, okay, got it.
Does it make sense? Any doubts, anyone else?
Yeah.
One question. So metadata service like a gateway, right?
Metadata service is being looked used by the gateway.
Okay,
So
okay, okay.
gateway is trying to
Uh,
route the request to the specific partition, and to
mm.
do that, it needs to know which partition the data is located. For that, it's
Okay, okay,
trying to call the metadata service.
okay. Got it.
Shall we start reading?
Yeah, I was just looking for. There was one a good article on this for some details. I was just trying to look. Give me 1 second. Yeah, so I think yeah. So someone has asked this question: why is the load balancer needed between the front end and the metadata service? I think it's something different than what I mentioned. But yeah, it could be a good read. Someone has asked this question actually, so I'm sharing this in group. Feel free to take a look whenever you have time. So similarly, over this educative discussion forum, like people try to pose this similar the questions that we usually discuss here. So feel free to take a look there. It could be a good learning. Okay, yeah. So going forward, okay. So like the components of high level design, front end server. Front end server is like the gateway server that we were talking about. Then the gateway server load balancer could be part of the gateway server. Or it could be separate component. Then we have a metadata service, and then the backend service. A vital part of the design in organization of servers at the back end of queue creation, deletion, and other operation. The next lesson focuses on organization of backend servers and the management of queues, along with other important operations related to the message delivery and retrieval. Okay, let's go to the next. Can anyone take up the reading? Someone who hasn't done before, maybe let's start with that, and then within 10 minutes we can rotate by anyone. Like,
So I can take it today.
sure.
Okay, backend. Okay, backend service, right? Okay. So yeah, so this is a core part from here, right? So this is a core part of the architecture where where major activities take place. When the front end receives a message, it refers to the metadata service to determine the host where the message needs to be sent. The message is then forwarded to the host and is replicated to the relevant hosts to overcome possible availability issues. The message replication in a cluster on different hosts can be performed using one of the following two models: primary secondary models and a cluster of independent hosts. So message of replication on different hosts in the sense like can be where is the one diagram I had seen, right? Above, I think. Yeah. Okay. I had seen some. So before before delving into details of these models, let us discuss the two types of cluster managers responsible for queue management: internal and external cluster managers. The differences between these two cluster managers are shown in the following table: internal cluster manager and external cluster manager. So internal cluster managers, it manages the assignment of the queue within a cluster. And in the external cluster manager, it manages the assignment of queue across the cluster. And internal cluster manager, it knows about each and every node without a cluster. And it in external cluster manager, node about each cluster. However, it does not have information on every host parent inside the cluster. But here, every node, which one? The cluster in the sense they are talking about the microservice perspective, right? Right, Sagar?
I didn't get your question quite a bit.
I'm saying that here in second line, internal cluster management they are talking about each and every node within a cluster, right? So node, so it is talking about the cluster, whatever Microsoft deployment, right?
Knows about every cluster. Yeah, so it knows about every cluster. That means, like, consider that there is a mapping which exists, that like these are the clusters available and live at this moment, and this, let's say, it could be just a list. That list is saved at every single node.
No, here cluster means what they are talking, because one cluster we talk about the Microsoft Kubernetes term, right? Where in one cluster we have multiple nodes.
Correct.
So is it different from that or is it the same?
Yeah, it's just a group of servers, right? Group of nodes.
No, same it is then. Okay.
Yeah.
Then it is same. Okay, then it is same. I think not in the sense one physical machine they are talking about, group of the server. Okay.
Yeah. So consider that there is one manager. This is more like an internal cluster manager, as in, like, every single node could know about every other node. Versus there is a separate manager agent which knows about every other node.
Yeah, correct. Yeah, that's so. It in case of internal cluster manager, it listens to the heartbeat from each node. Yeah, that's correct. So that they can find it whether it is alive or not.
Yeah.
In case of external, it monitors the health of each independent cluster. Yeah, this is logically correct. So, and it manages host failure, instance addition, and removes from the cluster. In case of external cluster manager, it manages and utilizes clusters. But in case of internal cluster manager, it partition a queue into several parts, and each part gets a primary server. Okay. And in case of external, it may split queue across several clusters so that messages for same queue are equally distributed between several clusters. Okay. Everybody clear, right? Okay.
Yeah.
Do
So
we
little bit. Yeah. Go ahead.
so do we need like both internal and external, or it just like either we can use internal or external?
Yeah, it's either or. Like if you see, like one of the following two models, right? They have same. So this is more like a, like we have a primary secondary, right? We have like a master slave architecture type topology, right? So the first one is more like a master slave, and the second one is more like a independent of master slave master. That is, this could be look like as a leaderless kind of a strategy, and this is more like a master slave kind of strategy. So to reiterate what Rakesh was mentioning, uh, the master knows about every other node. So this is specific node that we are talking about, and here everything is about cluster. So cluster is nothing but group of host or group of partitions. Partition is where like host is where the partition is stored, or let's say we to create a distributed message queue at a huge level, the most primary unit of that is a single partition. So let's say if I am using queue in my application, my queue would be broken down into, let's say, uh, 10 such partitions or like 100 such partitions. So it will never be a single partition as a queue. Let's say if I'm sending 1 GB of data from producer to consumer, it will never be just one partition. It will always be a cluster of partition. So now, whether that cluster will be a master slave type, or whether that cluster will be a consensus based, consensus as in like it will, they will manage itself independently. There won't be any primary, or there won't be any master or manager or sort of thing, or primary sort of thing which is managing the data over it. So the first one, internal cluster manager, is like the one which I mentioned, whereas this one is more like it has the external cluster manager, which is like it is just trying to bring up and bring down any of the clusters, or it just tries to know about which clusters are healthy or not, and based on that it will just try to spin up new clusters. But internally, the clusters knows about the cluster will try to propagate the information everywhere, like that. So it says it may split a queue across several clusters so that the message for the same queue are equally distributed between several clusters. So here they just, based on the load, they just try to distribute it by themselves. Whereas here the primary tries to distribute the messages to various partitions. Slightly confusing, but at this moment this could be ignored if you guys are finding it tough to, to relate this to. Going forward it will be pretty much clear once we go down and
I
discuss it
think
in
in
detail.
the first one, I think it's just talking about a single cluster, right? And it partitions a queue into several parts. Basically, it partitions the queues among the nodes which are present on that cluster, right?
Sorry, I didn't get you.
So basically, for the internal cluster manager, the last point, it partitions a queue into several parts, and each parts get a primary server. So it partitions the queue among the nodes which are present on that particular cluster, right?
Yeah, okay.
The
Okay.
last one, the last point.
It partitions the queue into several parts, and each part gets a primary server. Yes, correct. Yeah.
And I think in the external one, it partitions the queue among different clusters.
This is slightly confusing, I would say. To me, the way I understand, in my opinion, this is more like a different. Like there are two types of managers. One is
Hmm.
the cluster manager. The manager is part of the cluster. Then what will happen? And if this is an external cluster, then it will be more like an independent one. That's how I understood it, but I might be wrong. Like we covered, I think it might be more clear once we cover.
Yeah.
But yeah, to me, it occurs that these are two parallel models. It's not like I think there could be possibility that what you mentioned, but I think let's go forward and like clarify this.
But your understanding is correct, sir, because here in this case it will be multiple, right? So see, one
Yeah,
cluster in the sense we have a group of nodes in one cluster,
correct.
right? And external cluster in the sense we have a group of clusters, right? So that's why here same the queue are equally distributing between the several clusters,
Yeah,
because
yeah, yeah. Due to this
we have
statement only, I
yeah,
feel these are two separate things.
correct, yeah. So we'll have to do in this way, otherwise it will not fit in the design.
Makes sense. Makes sense.
Yeah, so yeah, can we go down here?
Yeah, let's go.
So am I reading fast or is it okay? Uh,
Yeah, wherever I think wherever some critical thing comes in, you can slow down, and rest of the
okay.
thing are good.
Otherwise, the speed is fine.
Yeah.
Or okay, thank you. So primary secondary model. In the primary secondary model, each node is considered as a primary host for collection of queue. The responsibility of a primary host is to receive requests for particular queue and to be fully responsible for data replication. So the request is received by front end, which in turn communicates with metadata service to determine the primary host of the request. Yeah, so yeah, obviously that's the request always feels got to will be received by the front end, then it will communicate to metadata service, then it will go to the metadata service, and which determines the primary host where to send, right? Okay.
So where sorry, I have one question. Where it replicates the data like that, so whoever is handling that request replicates data on like itself, like on that server only.
Sorry, I
Yeah.
think your question is not clear to me.
So basically here it says that a request go like a particular request goes to a particular primary host. So where the data replication happens, like where the data like is it get replicated on the same server?
No, no, it's always replicated or secondary, right? Like, like it just like primary just receives the request, but it always replicates it on any of the secondary nodes. So there could be several replicas. So what's the use if you are trying to replicate it over the same server? If it goes down, if it crashes, your data will be lost, right?
Yeah, that makes sense.
Okay. So for example, suppose we have two queue with the identities 101, 102. Can we go up, Sagar, so that we can
Yeah.
parallelly check the
Yeah, sure.
picture as well?
Yeah, also yeah, before going forward, this is the line I wanted to actually highlight. Sorry to interrupt you, Rakesh. So it says
No,
the
not a
request is
problem.
received by the front end, which in turn communicates with the metadata service to determine the primary host of the request. So like so far we were wondering what's the main use case of metadata service here. So this is where like the front end service is actually trying to find out the primary. Okay. And the request will go to particular primary of wherever the data is located, and then like as we were discussing, like primary will take care of all the replication stuff. Yeah, go ahead. Is it good now?
Yes, sir.
Okay.
So for example, suppose we have the two queue with identities 101 and 102 residing on four different hosts A, B, C, and D. Parallelly, we can check the picture also, it is mentioned clearly. Okay. Can we go up actually? I have not started. Yeah, sorry. So as a front end receives the message queue, it identifies the primary server from the internal cluster manager through the metadata service. So the message is retrieved from primary instance, which is also responsible for deleting the original message upon the usage and all of the replica. So okay, so metadata is responsible here to to go to the particular host. I think. So as shown in the following illustration, the internal cluster manager is a component that is responsible for mapping between the primary hosts, secondary hosts, and the queue. Primary host, where is the primary host? Yeah, sorry, here. Primary host, secondary host. Okay. So primary host is here, host B and D, B and D is a primary host, and yeah, and host A, okay, A. Secondary host is A and C. Okay. So as shown in the following, so internal cluster manager is a component that is responsible. I read up to here, right? I think. So.
Rakesh, can we read again from like starting, for example?
Example, okay, sir. So for example, suppose we have two queues with identity 101, 102 residing on four different hosts A, B, C, and D. In this example, instance B is a primary host of Q101 and secondary hosts where Q101 is replicated are A and C. Okay, A and C is replicated. Okay. As the front end receives message request, it identifies the primary server from internal cluster manager through the metadata service. Right? Is it clear up to here? Because metadata service, it is coming and finding the host where to map. And the message is retrieved from primary instance, which is also responsible for deleting the original message upon usage and all. What is the last? I did not understand. What is that? The message is retrieved from primary instance, which is also responsible for deleting the original message upon usage and all out replica.
Yeah, so when the message is consumed, we need to delete it, right? Consider the basic model of message queues.
Hmm.
When it is
Oh,
dequeued,
okay.
we want it to be discarded or like deleted from the
Oh, got it,
available
got it,
message.
got it. Okay. So, oh, okay. Oh, once it is received, okay, got it. Then we will get it. Okay, fine. So, as shown in the following
So consider
illustration,
this. Consider this model. The consumer will, let's say, if the consumer is consuming a message number 100, the consumer will try to ask for the next message as 101, and then it will try to request for 102 and 103 and 104. Like, so there will be some mechanism which will try to read 1 2 3 4 5 like these messages. Once they are read, it should be deleted. So whenever the time will come to read the 101th message, it should be deleted, right?
correct, yes. Okay.
Am I making sense?
Yes. Yeah, true. So, as shown in the following illustration, the internal cluster manager is a component that is responsible for mapping between the primary host, secondary host, and queue. Okay. Moreover, it also helps in primary host selection Therefore, it needs to be reliable, scalable, and performant. Okay, if you want some, if other people want, can start reading.
Yeah, so far any doubts anyone? So this is nothing but like it's about same thing that so far we have been discussing with the metadata service. It will know that its host key is a primary. The request will go to host the primary, and then the primary will take care of deleting, replicating, whatsoever. Okay, let's anyone wants to read further? So now is the critical thing, like the cluster of independent host.
Sure, I can go ahead. A cluster of independent hosts. In the approach involving a cluster of independent hosts, we have several clusters of multiple independent hosts that are distributed across data centers. As the front end receives a message, it determines the corresponding cluster via the metadata service from the external cluster manager. The message is then forwarded to a random host in the cluster, which replicates the message in other host where the queue is stored.
Can you read again this part?
In the approach involving a cluster of independent hosts, we have several clusters of multiple independent hosts that are distributed across data centers. Uh, uh, can you explain that? We have several clusters of multiple independent hosts that are distributed across data centers. I think it is just
Consider,
talking about. Yeah, go ahead.
so consider we have 2 3 independent cluster. We
Hmm.
just group them together in one cluster. Okay, now the whole queue is made up of such groups. Each group has independent host. There is no manager, there is no primary in that. So consider this is a cluster. Okay, here, if this is a cluster, consider all hosts are independent. There is no host which is primary, and there is no host which is secondary. Consider all of these are independent hosts. Now this is just one cluster. There could be
Okay.
such groups, like there could be multiple such groups. All of those groups are being managed by an external cluster manager. So
And those.
instead of one prime fitting one primary in every single smaller cluster, they just created one giant
uh,
external cluster manager, and
and-
then that external cluster manager is responsible for managing all the cluster groups.
okay, and these all the groups of the small clusters are distributed across data centers.
Yeah, yeah, it could be anywhere.
Okay.
And they are replications of each other, or they are just different.
Oh, this sounds familiar.
Oh, same here. Is Are they like different among the different data centers? Is it like they are replicated, or
Yeah. So like more like the cross DC in DC replication I was talking about. It could be like one of the cluster could be out. So let's say you have a bank of hosts available. Any four could be grouped together in a single cluster. Now it doesn't matter whether they sit in same data center or the different data centers. That could be one possibility. Another possibility is like one cluster is in current data center, one cluster is in different data center. All of them could be controlled by by the external host, external cluster manager.
okay?
So consider okay, yeah, so let's consider something like this. Every team has one manager. Okay, which manages the team. and there could be, let's say, 10 teams, and over those 10 teams there could be one director. Consider a scenario where there is no manager at all, there is just director, and every single person is trying to report to the director. But like not all of them are part of same team, they are part of some core smaller team of 4 people. So it's team of 4 people, but there is no manager in that. All of them just reports to the director. Does it does it make sense? Whereas every single team could have a manager, and the manager, there is no director on top of manager.
So basically, in previous approach, manager used to be the primary one,
Yes.
and other uh, reporters used to be the secondary. In this case, there is no concept of primary or secondary or the master slave. Everybody, uh, every host is the independent identity.
Yeah. Yeah.
There is just external cluster
Yeah,
manager.
and every single host actually reports to the external cluster manager.
Yeah, okay.
Okay.
Can you scroll up?
Yeah, sure.
There's a question. Okay, I'll read again.
Anyone else has any doubt, feel free to.
In the approach involving a cluster of independent hosts, we have several clusters of multiple independent hosts that are distributed across data centers. As the front end receives a message, it determines the corresponding cluster via the metadata service from the external cluster manager. Okay, so in the initial approach, front end used to talk to the metadata service and tries to determine the corresponding cluster with the help of the internal cluster manager. But instead of that, here there is an external cluster manager,
Correct.
and then okay, the message is then forwarded to a random host in the cluster, which replicates the message in other hosts where the queue is stored. Okay, how does a random host within a cluster replicate data, that is messages in the queues on the other hosts? Okay, how does a random host within a cluster replicate data, that is messages in the queues on other hosts within the same cluster? It has a mapping.
Any guesses? Any?
I think each host will have some map or something.
Do they again use external cluster manager for that?
Any more guesses? Without with yeah, there is one thing, that it could talk to the external cluster manager, but can that be done without external cluster manager?
Hmm.
Okay, yeah, let me open it. So I think there is some, yeah, this is one thing to think about. And similarly, there is this leaderless architecture as well, right? So in leaderless architecture, also we need to take care of the replication. So any server needs to take care of the replication part, so that these two are like nothing but the same thing.
So in the
Yeah,
sorry,
go ahead.
go.
Go ahead.
No, I'm fine.
Yeah.
Uh,
Okay. So it says each host consists of a mapping between the queues the host within a cluster, uh, making the replication easier. So the mapping which we are talking about in terms of I think metadata service mapping, right? The
Hmm.
same mapping could exist for a particular cluster as well. So whenever the request comes in, internally the host will try to manage among themselves for the particular cluster. So let's say, consider an example, earlier example, where the team doesn't have a manager. Now a request comes, and how can someone know that which work to be allocated to which person? So let's say if it's a team of four, or four, all four people knows that, like, who has what subject matter expertise. So since all four people knows like who has what subject matter expertise, whenever the request comes, it could be, and whoever gets the request first, he could actually do it himself if that person is a subject matter expert, or he can transfer that request to someone else in the team of four people, whoever has that subject matter expertise, right? So you don't need a manager to allocate a particular work item, or Jira task to a particular person. Even if it is received by another team member, if they know the subject matter expertise of the other person, then they can do that. So all they need to know is whoever person has which what whatever subject matter expertise is. So they will just maintain a map, like this person knows this skills, this person knows this skills, and this map would then be shared with every other team member. So everyone knows what are the competencies of every team member. So just like that, here this map is nothing but a qid is our particular message request, and whichever host has that, we are just listing those hosts. So let's say this current cluster of four nodes, it could be handling IDs between 100 to 200. And so whenever a request comes in for 101, it will see that it could be served by node A or node C. So let's say if this request is received by node B, then it can either route the request to node A or node C. And let's say 103, this request is received by node B again. It knows that like this 100, it already has the 103, so it doesn't need to route the request to anywhere else. It will just do it itself. Now, how is it different than the primary secondary model? This mapping exists at a primary, so only primary knows about which ID is stored on which server. Except here, this mapping is shared with everyone else. Sorry, every other server in the cluster. Does it make sense? Anyone has any better explanation than what I explained, or like slightly confusing? But yeah.
Can we read this? Whatever is written over here,
Sure,
assume
sure.
that.
Yeah, sure. Go ahead.
Okay. Assume that we have a cluster, say Y, having hosts A, B, and C. This cluster has two queues with IDs 101 and 103 stored on different hosts as shown in the following table. Okay. This table is stored on each host within the cluster Y. When a random host receives a message, say host C, for a queue having ID 103, host C replicates this message on the other host where the queue 103 is stored, that is node A and node B. Um, so it's talking about the host as well, and then it is talking about the node as well.
Sorry, I was a bit distracted. Can you come again? Like, what was your question?
So it says, I mean, now, uh, okay, host we understand. Is the host and the nodes are the same thing?
Yeah. Here I think the host and node, like I think they just have a typo here, but I believe the host and node is same thing.
So it says that assume that we have a cluster Y having hosts A, B, and C.
Hmm.
The cluster has two Q, 101 and 103 stored on the different hosts
Hmm.
as shown in the table. The table is stored on the each host within the cluster Y. When a random host receives a message, say host C for okay, when a random host C receives a message, so let's say host C receives a message for Q having ID 103. Host C replicates this message on the other hosts where Q103 is stored.
Yeah. So consider this 103 is nothing but a queue,
Hmm.
and a message comes in which is intended to be stored in Q103. Okay.
Okay,
Now
okay.
this 103 is nothing but a
Hmm.
partition of a big queue. Okay. So
Okay,
this 103 is a queue ID, and there comes a message from a producer which is supposed to be stored in Q103, like 103th part or 103th fraction of the whole
hmm.
queue. Okay. So that request is at the very first time received by host C. Okay. So
Okay.
host C has this table. It will see, it will
Hmm.
check 103, it will look up 103, and it will find out that 103 is stored on node A and node B. So it will try to ensure that the message will be enqueued in node A as well as node B.
Okay.
So here the replication factor is 2. So whichever host receives the message, it will try to look up the queue, corresponding queue. Now this queue is stored on node A, and the request then be sent to node A to store that message into its queue. So earlier we were talking about just message in terms of messages, right? This language is more like in terms of a partition, just like they are giving this ID to a partition. So whenever a message is coming in, they are just trying to store it in particular partition. There is no difference in what we discussed earlier and what they are talking out here. Make sense?
Okay, sounds good. Does anyone has any other questions?
Not a question, but it's like something. Each node has information about everyone, right?
Yeah.
So if the request comes to anyone, you just check if that queue is not assigned to each that particular host. So it look for others and just route to that one, right? So in this random one, correct?
Just one, yeah, everything is correct. Just one line that they added is that C take cares of the message being replicated in both.
Mhm.
Okay. So
Okay.
if the request is received by C, it not just routes that request to A, it ensures that A successfully stores it. Similarly, it won't just route it to A, it will ensure that the request is stored in A as well as B.
Okay. Yeah.
So consider like when if the request is received by C, C is temporarily acting like a primary. Whenever it gets this information, it temporarily acts like a primary, and it ensures that the message is stored in A as well as node B. Similarly, if a request is received by B for let's say 101, then B will ensure that the message in for intended for 101 will be stored successfully in node A and node C. That means, what does mean by stored successfully? It will wait for the acknowledgement to be received, that the message is successfully stored in as well as successfully stored in B. If the message is successfully stored in A and and not in B, then it will try to retry sending that request to B again and again until B successfully stores it. So whichever a host receives the request, it's the responsibility of that particular node to store that request. Make sense?
Yeah.
Yeah, so this is nothing but like a leaderless application, like the what I was talking about, right? This is nothing but a leaderless application. It just tries to broadcast the message. So if C receives the message, it just tries to broadcast to whichever nodes are responsible for that particular queue, and it just ensures, and it just waits until the message is successfully stored by these them. This is how, this is nothing, this is same as how it works in Cassandra. Okay, so like, like if you guys might be having some learning curve over here, but same patterns you can find out in other system design as well. So it would be, once you found out that that this same leaders application is part of some other databases, you will easily grasp the other databases or other system design problems. So just like try to pay attention to the concepts. It might not be clear in the first read itself, like, but we'll try to repeat it, or we'll try to reread it elsewhere as well.
So if a 101 QID goes request to a correct node, for example, node A, then node A make sure, does like node A make sure that it also gets replicated on node C?
Yeah, yeah, definitely. So since
Okay.
node A itself has the data, if it is putting any message into itself, it will also ensure that it should be put into the rest of the nodes as well, like node C here.
Basically, to whatever hosts the request will land, it will act as a primary for that particular message. I mean, when I say primary, that it will store the message in itself as well and make sure the message is stored in the other host, messages being replicated to the other hosts or nodes
Correct.
as well.
Correct.
Okay, so shall I read further or
Yeah,
do we
guys.
want to stop
Um
here?
I just have
I
one question.
Sure,
Hello.
go ahead.
Yeah, like it's a leaderless application where like, but where we have a mapping for this queue and node actually. If we are not talking about the cluster, so if where exactly they have information about this one, which queue is stored on which nodes or server.
So consider that this map of which queue is stored where is everywhere in every single cluster, on every single cluster. Sorry, my bad. Every single host.
If you
Okay.
scroll down, Sagar, there was a diagram also. I think that will, yeah.
Yeah. So if this is a cluster, every single host has this map. If this is a cluster, every single host has this map. If this is yeah, just like that.
Okay.
Why they don't have that map in external cluster manager?
External cluster manager has all the maps combined.
I mean this map as well, like which is within the cluster.
Sorry.
So that will be
So this is
that.
internal. Yeah, go ahead. Go ahead.
Yeah, I think she's asking about that the QID and the hosts map. Why isn't that map at the external cluster manager? So I think if external cluster manager will have that, then it won't fit into the. I mean, basically, that was the work of the internal cluster manager. That was the concept for the primary, secondary structure.
Correct. So, like I would add one extra thing to what you mentioned. So the job of external cluster manager is just to route the request up until the cluster.
Hmm.
Now it's the responsibility of the cluster to replicate it in itself. So this map is nothing but a replication copies. So whichever host receives the request, it tries to ensure it is replicated at both of these two. So it's among the team itself or among the cluster itself to know about where we who will take care of that message. or who will take care of that copy of the queues. The external cluster will just tries to send the request up to that cluster, which wherever it is intended. So let's say 101, so 101 and 103 both will just the job of external cluster manager is just to ensure that the request reaches cluster A. Now it's a job of cluster A. In cluster A, every single host has this responsibility of storing it in two hosts, that is making a copy or replicate that queue in other host. Does that make it easier?
Yes, I think we can continue
Yeah,
tomorrow.
so I need to drop here. I have a hard stop here. Yeah, do you guys want to continue or?
We're meeting tomorrow.
So generally we try to skip on Fridays.
Okay.
Friday, Saturday, Sunday we can take a break. But if anyone is interested in discussing and revising and stuff, feel free to join or feel free to like take it forward.
Sagar, one more question, like related to Kafka, right? The next topic is Kafka as per your
Yeah.
list. So in Kafka, where are we following the same document or?
No, no. So I will try to find out a good, better resource for Kafka. So once we cover the internals of the message queue, we will try to go about the Mikhail's video once, and then we can go to Kafka. So Kafka is where we will try to talk about his features that they have, offset,
Hmm.
dead letter queue, and
Correct, correct, yeah.
any. So that will be system design of Kafka.
Hmm. Okay, okay,
Similar,
sure.
but it will be more in detail. This is basics. This is basics of any distributed message queue.
Okay, sure. Thank you. And which video you're talking about, Mikhail? Like, is it related to
I
Kafka
shared
or
it
any?
the other day. The system design distributed message queue. I will try to
Oh,
share it again.
oh, okay, okay. Let me see. Okay, yes, yes, yes. One video I can see.
Yeah, yeah.
Okay, thank you, thank you.
Cool.
So, thank you, Sagar, thank you
Thank
all.
you.
Yeah. Thank you, everyone.
Thank you.
Bye.
Okay.
Thank
Bye.
you.
Bye.
Thank you.